Okay, I do not know what is the so-called the obstacles that you are facing, but assuming that you are talking about trying to show that the total surface area A is actually given as over here, and you had a problem in the sense that the y has to be replaced, right? So let's just assume that they have given us this. So we have to understand that there is an important thing that you need to know. We are actually given the total volume of the solid body. Okay, so it's given as 72, and we have to use this to find out what exactly is y. Okay, so that is why later on we will need to replace y with the appropriate value. So let's assume that we need to do that. We would have to find the volume of the solid first. Okay, so for instance right now you can see that we have got maybe a cuboid below. So the volume of the cuboid is actually just length times breadth times height, which is actually 4x squared times 2. Alright, and then of course we will add with the cylinder the volume. That will be base area times height. That will be of course pi r square. Now in our case here, the radius is actually x here. Okay, so we will do x to the power of 2, right? And then we will multiply it with our y. Okay, so that's how it works over here. And of course, let's just make it nicer a little bit. That will be the volume is actually equivalent to 8x squared. Alright, and then we have got a plus pi x squared y. Alright, so this is what we have, and let's just put in the volume. The volume over here is actually 72. Right, so we have got 72 equals to 8x squared plus pi x squared times y. Alright, so step by step we will have to isolate the y. So what exactly is y? So if I can do that, my y is technically going to be 72 minus 8x squared divided by pi x squared. Okay, so this is actually the y that we are supposed to express first. Alright, so this is what you are supposed to use as y. So of course, if let's say now I need to show that the total surface area is as they have shared with us, the very first thing is of course we need to know what exactly is the total surface area. It's rather tricky over here is because we have to account for certain aspect of this. Okay, so be very mindful that the top part over here, right, you have to disregard, okay, the circle area over there. Right, so we have to just disregard this, right, so by subtracting that, okay, from the top side. So technically it should look like this. So we will consider the 5 side first, okay, or we can do all 6 sides if we want. So that will be of course the parameter of the cuboid, which is actually 1 2 3 4 5 6 7 8x. Okay, so the parameter is actually 8x. Okay, and then we will multiply this with 2. Okay, that is actually the one that you see, right? And then we will add to the base area, okay, which is actually 4x squared. Okay, I can also add another 4x squared, right? Okay, just to show the top and bottom, but be mindful that this so-called surface area of the cuboid, right, later on this 4x squared has to be reduced. So we will, but then however we can just do something like that first. So we will have a 16x, okay, plus 8x squared. Okay, so that's what we are supposed to have right now. Now you will notice something. You will notice that we are almost near to that. So in your working, try to avoid taking anything away from 8x squared. Try to deal with the 16x. Okay. So what's next? We will now remove from this. Okay. So let me rewrite this as 8x squared plus 16x. Okay. So first thing, I would like to remove this area. Okay, so that will be 8x squared plus 16x, okay, minus the area of the circle, which is actually pi r squared. So that will be, of course, minus, okay, be careful, that will be pi r squared, pi x squared. Okay, alright, this is what we have. Okay, and then but because of taking this away, right, okay, we need to also add the top. Okay, so it actually remove this entirely. Okay, so that means now I'm removing this area from from the cuboid side, right? But yet you notice there's a top over there. Okay, now assuming that it is actually fully covered, okay, assuming that it is actually fully covered, then I will have to add back the pi x squared, so which is actually just 8x squared plus 16x. Okay, now I'm not too sure whether it is actually open, but I assume that it is enclosed. So now we have this. Okay, so that will be 16x. Okay, now next stop we will find the curved surface. Okay, so the curved surface is actually the perimeter of the circle. So the perimeter of circle is actually 2 pi x. Okay, alright, 2 pi x and then times y. Okay, so we will multiply it with y. Okay, that will be the curved surface area of the cylinder. So perimeter times height. So go ahead, 2 pi x times 72 minus, okay, blah blah blah. So let's just do it quicker. Minus 8x squared over pi x squared. Okay. So what happens now is you can cancel the pi. You can cancel the pi. Okay. And then the x can also cancel, leaving you with only one x at the denominator, right? Something of this sort. And then let's continue to multiply. Okay, so we'll just do that. So that will be, of course, 2 times 72. That will be 144. Okay, right, 144. And then that will be, of course, 2 times negative 8x squared. That will be negative 16x squared. Okay. Over x. Okay, so that will be over x. Okay. Right, this is what we have. Okay, so once having this already, right, we will put this together with this part over here. Okay, so let me just try to get a space first, and then I'll redo the working. Okay, maybe I'll just do it over here. Okay, so it's a bit messy, I know, because I made the diagram a little bit bigger. So, but assuming now we have got this, what we need to do next is to add them together. Okay, now if I got something different, it might be that your cylinder is not enclosed. Okay, but I'm assuming it is enclosed now. So right now what I've got now, I'll just add. Okay, so that will be 8x squared, right, plus 16x. Okay, and then I'll carry on, plus 144 minus 16x squared over x. Okay, so something like that. And remember, I told you this ax squared resembles our answer that we need to show, so do not use that. Instead, you will